Welcome to the notes on multiplying polynomials. This is lesson number 1 in our first unit. So I'm going to put a 1 at the top to help me organize my notes. So before we begin, remember the word polynomial. So this is technically review from your first year of math, but we need it because it comes up a lot in this unit, and it's on your unit test, and so it's important that you know it. But it's completely random for comparison to most of the units. Actually, the first 3 lessons are completely random, but then you use this information in the rest of the notes, and it starts all combining together. But at first, it's going to feel a little separate and different. So we're going to multiply polynomials, and if you remember, polynomial means multiple terms. Because poly means many and nomial means term. And so we will talk about what that means briefly. But first, remember the word distribute. Distribute is just the big word for multiply, but it means you're multiplying into a parentheses. So you multiply into each term in a parentheses. Okay. So, I also have to remind you what the perimeter is. And I'm going to write some things on the side here for this. Perimeter is like when you have a shape, let's say it's a square or a rectangle, right? And let's say you're making a garden bed, and in the middle you're going to put a bunch of flowers, but on the edging you need a fence to trap it. Well, your perimeter is how much fence you need, basically. It's how much along the edges. So let's say this is 2 feet and this is 5 feet. Your perimeter is when you add up the sides. Right? So if I were to add it up, 2 plus 5 is 7, but down here is 2 more, so that's 9, and over here is 5 more, so that's 14. So our perimeter for this one would be 14. And I'm just going to write it kind of small right there to help you remember. But then there's something called a product area. An area is how much space you need in the middle, like how much flowers you need. And to get that, you end up multiplying the length times the width. So our area in this case is 2 times 5. So I'm going to write that over here. Our product area of this one is 2 times 5. What makes it a product area is that it's written, it's the area, which is length times width, written with parentheses. So it's before you multiply it. It's like writing just the 2 parentheses, then the 5. And product is a big word for multiply. So it's like you're writing it as you're still multiplying it, right? The sum area is the area written after you multiply. So 2 times 5 is 10. So I'm writing a little 10 over there, right? And so the sum area is the area after you multiply. Okay? So these are really easy if they're just numbers. But sometimes they're not going to be numbers. They're going to be, well, polynomials. So it could end up being a square like this, where this isn't just 2, but it's 2x plus 1. 2x plus 1. And this isn't just 5, but it's like 5x minus 3. And then you have to tell me the perimeter, the product area, and the sum area. In order to do that, you have to know how to multiply these 2 things. And these 2 things are called polynomials because they have multiple terms. Right? And so that's the whole goal of this, is to be able to multiply the 2 different polynomials to each other so that you can combine them and get a sum area. So before we can do that, we have to remember the rules of multiplying. Remember that a positive times a positive, so a positive times a positive, like 3 times 4, is positive 12. But a positive times a negative, if they're different, it ends up being a negative 12. It's negative, right? If it's a negative and a positive, they're still different, so it's still negative 12. but a negative and a negative becomes a positive 12 because they're the same. Remember, this is only when we multiply. The rules for multiplying is if they're both plus or both minus, it's positive, but if it's different, it's negative. That's true for multiplying and dividing, but not for adding and subtracting. It's different when you add and subtract. With letters, remember a number times a letter, like 3 times x is just 3x. X times x becomes x squared because the exponent tells you how many times you're multiplying something to itself. So this little 2, it's tiny and it's always in the right hand corner and it's called an exponent. And we read this as x squared, or we could say x to the power of 2 because to the power of means it's an exponent. And it's how many times you're multiplying x to itself. So here's an x times an x, that's 2 of them being multiplied. So we put a little 2 up there. If it's a letter times a different letter, like x times y, we just write xy, like right next to each other. And here we have an x squared, so that means x times x, right? Times x times another x. So it becomes x cubed to the power of 3. That's a 3. Because there's 3 x's being multiplied together. So those are just the rules of multiplying. So when we want to distribute or multiply into polynomials, there's 2 steps. Step 1 is to multiply each term in the first parentheses to each term in the second. In the second parentheses. Okay? So first of all, you just make sure each one in the first one goes to each one in the second one. And then when you're all done with that, to finish it up, you have to combine like terms. Okay? Well, there's 2 methods that are commonly taught for how to distribute polynomials. The first of which is called an area model. So what you do is you take each term. So 3x is one term. In math, terms are separated by plus or minus signs. So 3x is 1 because they're not separated by plus or minus. But this minus 5 separates that 5, and negative 5 is like its own different term. So then I'm going to draw a line through them and then write negative 5. And this is going to be like my top. Okay? Then on the side, I'm going to make this a box. On the side, I'm going to write how many terms I have in the second parentheses. Well, first there's this 2x. And I'm going to draw a line to separate it from the other term, which is a plus 1. A plus 1. Okay? So now, what I've done is I've set up a little area model, this little area box, that will let us make sure each term gets multiplied to each other. So I want to make sure that the 3x from the first one goes with both of these, and the 5x from the first one, or the minus 5 from the first one, also goes to both of these from the other parenthesis. So to get this box, I do this 3 times this 2. So 3 times 2 is 6, and x times x is x squared. So that took this one and that one and multiplied them together. To get this box, I do this minus 5, this negative 5, with this 2x. So 2 times negative 5 is negative 10, and there is just the 1x. To get this box, I do this plus 1 times this 3x. So 1 times 3 is 3, and there's just the x. And then in the last box, I do this guy with that guy, and 1 times negative 5 is negative 5. So I've now done step 1, which is make sure that I've multiplied each term in the first parenthesis to each term in the second parenthesis. Step 2, I combine like terms. So I look at my boxes and I'm like, okay, this box has a 6x squared. I don't see any more x squareds, so that's it. It's just those 6x squareds. The next box, I see this minus 10x, and here I see a positive 3x. Those are both x terms. So here I have 3, here I have negative 10. So when I combine 3 with negative 10, I'm not multiplying them, I'm adding them together. So 3 and negative 10, when they're added together, is negative 7, and they're x's. So I don't change what they are when I combine them together. They don't become an x squared because there's 2 x's. It's just about how many x's we have. Here we have 3. There we have negative 10. So in total, we will have negative 7 x's. Finally, I'm left with this minus 5. There's no just number term for it to combine with, so we just write minus 5 at the end. So that's the box method, or also known as the area model method. There's also the arrow method. And here's how the arrow method works. You write down the 2 parentheses, so 3x minus 5, and 2x plus 1. And I take this 3x, and I draw an arrow to that 2x to say I'm going to multiply those two together. And 3x times 2x is 6x squared. Then I also make sure I take my 3x and I times it to my plus 1. 3x times plus 1 is plus 3x. Okay, so I made sure the first one went to both of those. I also have to make sure that my negative 5 goes to both. So negative 5 times 2x is negative 10x, and negative 5 times 1 is minus 5. No, it's the exact same things I got in my boxes, just a different picture, right? So then these two are my like terms. These are both x's. So I have 6x squared. 3 minus 10 was negative 7 x's minus 5. My answers are the same. The only difference is that if you like to use the box because you like the way that looks, or you like to use the arrows because you like the way that looks. So bringing it back up here to perimeter and area, if these are my two sides, this right here, when it's written like this with the 2 parentheses, is called the product area. The product area has the 2 parentheses. The sum area is this, after you multiplied it out. Okay? And then if you wanted to do the perimeter, you'd actually have to add them all up twice, because it's like this side shows up twice both on opposite ends, and then this side shows up twice on opposite ends. So you just add them up. 3 and 3 is 6, 2 and 2 is 4, so there would be 10 x's, and then minus 5 is negative 10, plus 1 is negative 9, plus 1 is negative 8. So your perimeter would have been 10x minus 8, but I'm not really asking for perimeter here. It does on the test, and there's one on the worksheet that will ask you to do the perimeter, but that's really just adding up your sides, and that's not the hard part. The hard part, or the new part, is multiplying the 2 out to get the sum area. Because product area is easy, it's just writing side times side in 2 parentheses. The hard part is then doing the multiplying it out to get this, which is the sum area. So I'm going to show you how this works when there's a bit more terms besides 2 in each. So I'm going to start, and I can put this on the top or on the side. Because of room, I'm going to put it on the side because it's only 2 of them. So there's a minus x and a plus 4. And I'm going to separate the 2, make my box. On the top, though, I have 3. So I have 6 x's, which is getting separated from the minus 3, which is getting separated from the plus x squared. Okay, and so this one has 6 boxes instead of 4. So when I start to multiply it through, this is a minus x. When I start to multiply it, 6x times negative x. Negative times 6 is negative 6. X times x is x squared. Negative x times negative 3. Negative times negative is positive. It's invisible 1 times 3 is 3, so it's a positive 3, and then there's an x there. A negative x times a positive x is going to be a negative. And x times x squared is x to the power of 3, or x cubed. Then in this box, 6x times 4 is 24 x's. Plus 4 times negative 3 is a negative 12. And plus 4 times x squared is just 4x squareds. So there's an invisible 1 in front. But now I have to combine my like terms, and when you write out expressions or polynomials, you always start with the one that has the biggest exponent, or the biggest degree, the biggest little number in the right-hand corner. So if you look, this one has a 2 for an exponent, this one has nothing, so it's an invisible 1. This one has 3, 2, this one doesn't even have a letter. This one only has this 1. So the biggest one is the 3. So we're going to write that first, the negative x cubes. Next I move to my x squareds, the 2's. Well, these ones, there's more than 1, right? Because there's negative 6 right here, and over here is a positive 4. So if I combine those together, negative 6 plus 4 is negative 2, and they're x squareds. Then I move to my just x's, and right here I have 3 just x's, and right here I have 24 of them. So when I combine those together, I have a total of 27 x's. And finally, I do my just number, and there's no other just number to combine with, so I just write negative 12 at the end. So again, when it's written like this was my product area, because the two sides are written with parentheses being multiplied. And this is the sum area, which is just the area after it's all been multiplied out. And then if I wanted to do it with my arrows, I write negative x plus 4 times 6x minus 3 plus x squared. I make sure these multiply together. So negative 1 times 6 is negative 6. X times x is x squared. I make sure negative x goes to negative 3, which is positive 3x. So negative times a negative is a positive. Negative x times x squared is a negative x cubed, because a negative and a positive is negative, and then x times an x squared, which is just 2 x's being multiplied, is 3 x's being multiplied, which is x cubed. And then the x, negative x, went to all 3 of these, but the 4 also has to go to all 3. So 4 times 6 is plus 24, and they're x's. 4 times negative 3 is negative 12, and there's no letter. And 4 times x squared is a positive 4x squared. Again, I rewrite it in order where I put my negative x cubes first. I combine my x squareds, and then negative 6 plus 4 is negative 2x squareds. I combine my x's, plus 3 plus 24 is plus 27 x's. And then I'm left with my minus 12 as my just number. And that is the arrow way that we find the sum area when you multiply two polynomials.